So for number 1, it says we're talking about 4 sine 2 theta. What kind of graph is 4 sine 2 theta? That'd be a rose. How many petals would it have? 4. So what would the interval be for this? 0 to 2 pi. This is a circle centered at 0 with a radius of 2. What's the interval of a circle centered at 0? 0 to 2 pi. Okay, so the trick about the circles, maybe we should graph this just to make sure I'm right. Circles that look like this, where they're like on like one side of an entire axis, those are the ones that are from 0 to pi. I am pretty sure that ones that are centered so that they go in all 4 quadrants, I think those are 0 to 2 pi, but let's just double check and make sure I'm right, because I'm a little bit unsure of myself. 0 to 2 pi. I always change my theta step so it slows down. R equals 2. So 0 to 2 pi appears to be good. Let's check and see if 0 to pi would have given us the same thing. Okay, so I was right. Woohoo! That's good. That's a good thing. So if your circle shows up on like just the right side of the graph, or maybe your circle is just at the top of the graph, or maybe your circle is here, those circles are from 0 to pi. And then if your circle is like this, it would be 0 to 2 pi. And really, it's kind of intuitive, I think, because you just think about how many quadrants does the circle show up in. These circles only show up in 2 quadrants, so 0 to pi would graph them. Those show up in all 4 quadrants, so 0 to 2 pi. Yes?
Why do you say 0 to pi rather than like pi halves or 3 pi halves?
Pi halves or 3 pi halves would do exactly the same thing as 0 to pi would. So I think that's just like the default setting, and then we can adjust it if we want to. Yeah. Okay, so based on the way that these are both written, can you hit the first light switch, the one closest to the door? The other first? Sorry. But yes. The second one? No, you're good. You're good. If we were thinking from left to right, the left one really should be the first one, but I was thinking first as in it's the closest to the door, which you were walking out of, you know what I'm saying?
Yeah.
All right. So 0 to 2 pi. Okay, so let's go ahead and graph both of these. So we have 4 sine 2 theta, and r equals 2, and we're probably going to want to adjust the intervals to make sure that we zoom in a little bit so we can see everything. Oh, I forgot I said 0 to pi. Change your window back to 2 pi.
No. I mean, it's not like, how do you dial it?
Well, letters are the same as the number. You just look at which letters on that number.
So you include like hyphens?
You can't. I think you just dial it like you would a normal number.
I did do that, and when I dialed it, it works. I didn't do one noise.
Well, that's what I thought.
So anyway, back to math. So let's go ahead and draw this picture as best we can. So we have a circle on top of what looks like a butterfly. I know it's a rose, but I feel like it's a butterfly. Find the common area between them. Can you guys tell what the common area between them would be?
So it's the area.
Yeah, and it would have to be the area that looks like it's on top of a petal, but only inside the circle. So this little triangle over here, that is not the common area, because that's part of the circle, but it's not part of the petal. Okay, so the common areas would be these parts right in here. All right, and what I'm going to go ahead and do is I'm going to kind of zoom in. So this goes 1, 2, 3, 4, 5, 6. I can maybe make this go to -4 and 4. And then, there we go. Now I can see better. Okay. There we go, so we can see. Okay, so what we want to do next is what? Do you guys remember the next step in the process? Andy, wake up. With your eyes closed. Andy, with your eyes closed, looking all relaxed with a little bit of drool.
Excellent talent.
All right. So what's the next process if we look at the example problems? Yeah, find where they intersect each other, and how do we do that? Set them equal to each other. So we're going to say 4 sine 2 theta equals 2. And how do we solve this? Divide by 4. Sine of 2 theta equals 1/2. And we're not going to make the mistakes in solving these equations now, right? So I'm going to say 2 theta equals something, 2 theta equals something. Where on the unit circle is the y-coordinate positive 1/2? And what am I missing? Plus 2 pi k. Yeah, don't forget that. Then it'll be as though you never had the 2 in front of the theta. It'll mess up all your answers. Okay, what do we do next? Divide by 2, 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 divide by 2. So we have theta equals pi 12ths plus pi k. Theta equals 5 pi 12ths. Okay. So that means that altogether theta equals pi 12ths. What's 1/12 plus 1? 13 twelfths, plus another 1 is too big. And then we have 5 twelfths plus 1, 17 twelfths, add another 1, it's too big. So those are all of our lines right there. Okay, so what I'm going to do is I'm going to focus in on just the first quadrant, okay? Because if you look at this, do you guys see how there's symmetry? So if I could find 1/4 of the area, I could just multiply it by 4, okay? So I'm going to focus in on the first quadrant, okay? So if we draw like an extra large picture of the first quadrant, it would have a petal. That was a pretty good petal. Thank you. Thank you. I would take a bow, but then I'd have to get up, and let's do that. Okay, so this is the area that we're finding if we're just considering the first quadrant. And then if we think about where those angles should show up, they would go like this. There's pi 12ths. What's this one right here? 5 pi 12ths. Aha. Okay. So what's the next step when we do these problems? Yeah, figure out which interval we should use from the circle and which interval we should use from the rows. Okay? So I'm going to say circle, rows. Okay. For the interval from 0 to pi 12ths, should we use the circle or the rows? for the interval from 0 to pi twelfths, should we use the circle or the rows? The rows. Because the circle, you would find this whole sector. Is that what you want? No. So for that first interval, if we do from 0 to pi twelfths and we do the rows, it will only do this part of the rows, which is exactly what we want. So I'm going to say for the rows that we're going to do from 0 to pi twelfths. Okay. Which one do I want to use from pi twelfths to 5 pi twelfths? The circle, because if I do the rows, then I'm going to get all of that, and that's not what I want, right? So if I do the circle from pi twelfths to 5 pi twelfths, then I just get this part. Okay? And then which one should I use from 5 pi twelfths to pi halves? I should use the rows. Okay. So what I'm going to do is I'm going to call these little pieces on the side slivers. Are you okay with that? Okay. How many slivers are there in the entire picture? There's going to be 8, right? 2 per quadrant. 8 slivers. The middle part I'm going to call a triangle. How many triangles are there in the picture? 4. Okay. So if we know there are 8 slivers and only 4 triangles, that means we can kind of narrow it down so we don't have to use both of these and write 2 separate integrals. We can just ignore that and only write 1. Okay, because this represents the sliver and this represents the triangle. Okay, I'm going to go ahead and maybe draw some arrows to that. Not because I don't understand it right now, but because closer to exams it might be nice to have that to look back on. Okay. So let's go ahead and start using our formula, right? So we have 1/2. I'm doing my area formula. So for my slivers, I have from 0 to pi twelfths. And then what else should I be writing? The equation for the rows. So 4 sine 2 theta squared, d theta. And then because this represents the slivers, I should put 8 in front. 8 slivers.
Looking at the grocery store and you scan the same thing twice.
Yeah.
You've got 2 different flavors but the same size.
Yes, exactly right. Plus, what will I do without you next year, Isaiah? I will be like, who can give me pointless information about something else? I know, I'll be like, Isaiah, I need a random tidbit. Give me a random tidbit.
Just call that hotline. No help.
All right, so what's my next interval? So 4 for this one. Marvelous. Is it possible for us to do this by hand? So let's think through. We're not going to do it by hand, but let's think it through so that we know what would be required. What happens when you square this part? Okay, it's 16 sine squared 2 theta. Can you integrate that by hand the way it looks right now? No. What would you? Power reducing. So you'd say 16, and then you'd have 1 plus cos 4. It'd be 4 theta. You wouldn't be able to evaluate it and get like a decimal answer, and you wouldn't be able to evaluate it. Actually, technically, you could use half-angle formulas and do pi 6 divided by 2 to get pi twelfths, technically. I wouldn't make you do that, but I'm just saying, I'm making the point this is possible to do by hand, okay? So we could have done this problem by hand. We're not going to, but we definitely could have. Okay, go ahead and plug it in, see what you get. what do we get? 9.82.
Well, not in net,
So check and see if you have a typo, maybe. Now, today I was looking back to find FRQs for polar, and what I noticed is that more often than not, they end up in the calculator active portion of the FRQs, which can be a good and bad thing. We've realized, right, what happens with the calculator active ones are sometimes kind of hard because you have to know how to use your calculator well.
what was this? I don't know.
Got it? You good? Okay. Are we ready to try the next one? Okay. So let's go ahead and get it typed in. What kind of graphs are those? 1 plus sign, 1 minus sign? Do you know off the top of your head? Cardioid. They're cardioids. Because they're both 1 and 1, right? 1 plus sign and 1 minus sign. What's the interval for both of these? 0 to 2 pi again. I don't know if our window might be okay. We'll see if we need to make it. Well, we could even make our window smaller so we could see better. It looks like a really round person with little butt cheeks. You know? like, well, at first when it was just that part. Anyway, all right. So I'm gonna go ahead and change my interval to maybe go from negative 2.5 to 2.5. I like it when it like fits the graph more. I always end up squinting. I'm like, I can't see it. It's so small. See, there's a little butt. Yeah. Yep. So I did 0 to 2 pi, and then for my x and my y, I did negative 2.5 to 2.5. Or you could probably even do negative 2 to 2. All right. So what is the common area that we're looking at? In between the butt cheeks. That was an awkward way to phrase it. That was a real awkward way to phrase it.
Glad I'm in this thing.
Oh, man. Okay, so if we draw the picture, we have butt cheek, circle butt cheek, butt cheek, butt cheek. And we're finding this right here. And there's some symmetry there, right? So it makes it so it's going to be a little bit easier for us to find the area.
Oh, so we only need to find one of them.
Yeah, if you think of this as being like 4 pieces, it's like 1, 2, 3, 4, and so you have these like kind of half circles. There's 4 of them, so if we can find one of them or find 2 of them, then we can find the whole area. Okay, so what do we do next? Set them equal to each other. So we have 1 plus sine equals 1 minus sine. And then what do we do? So the 1's cancel, and we can get the signs to one side. So sine theta equals 0, and then what does theta equal? Zero pi, 2 pi. So if we think about that, that's basically telling us to draw the line right here. which kind of makes sense, right? Because if you watched it when it was being drawn, it did these two little bloops in a row, right? So if you want to kind of, if you want to make it a little bit easier to see one part at a time, what I would do is I would delete one of these. So let's go ahead and delete the second one. And we can figure out exactly what interval would get those little bloopy half circle parts. Do you like how I'm calling them bloops?
That's
But-
what my little sister and younger brother call poops.
Poops? Bloops? All right, so let's say we're going to use the first equation instead of using the second one, so we're going to focus on the first one, okay? And when I graphed it, it looks like this, and so I'm specifically going to find these two areas, and then whatever I get for this, I'm going to double, okay? Now, it says that our intersection is at 0, pi, and 2 pi. We are finding the little half circles that are on the bottom. So what's your anticipation as far as what the interval should be? Pi to 2 pi, okay? So if we want to check it and see that we're right, we can hit our window and change your interval from pi to 2 pi. And if you did it right, then it should only graph that part. And then you'll know, okay, yes, that's the right interval for me to find. And there it is, just a little butt. And we're finding it.
Or a cat smile. We can,
No, definitely a little butt. All right. So we have our area formula as 1/2. What am I going to put in front of the 1/2? 2, because we're finding the bottom butt cheeks and the top butt cheeks. And then what's the interval? Pi to 2 pi. All right. And what should I write? All right. So that one is ready to plug in. Yeah, let me sit down.
it's a little fun, sorry.
What I've noticed about these FRQ questions is that they typically give you a picture to look at. So that's something good that makes, I think, will make our lives a little bit easier, is you can, to a certain extent, you guys have used your intuition for some of these, right? Like you knew it was pi to 2 pi because it was the bottom of the, it was the third and fourth quadrant, so that sort of thing I think you should still be able to do during the test. All right, and we should be getting 0 point something.
7.
Marvelous. All right, I know, I'm guessing arc length and surface area are good. Yeah, so you have 2 more problems to practice. I'm gonna let you guys try those, but I think now that we've seen these two, we've seen some more examples of kind of the same thing. Hopefully they make a little bit more sense. I would say too, I don't know, Desmos can kind of be a pain when you're doing it on your phone because it's so small. The one thing I like about Desmos is it does do these in different colors, and so you can kind of tell which one is which a little bit more easily. So I'd say you might try using Desmos instead of your graphing calculator. To graph these in Desmos, you literally would just type r equals 1 plus sign, and then you would start to spell the word theta, T-H-E-T-A, and once you start spelling it, it will put a theta in there for you, and it will graph it in polar. So Desmos does polar just fine, okay? If you wanted to use that instead, I'm okay with you guys using your calculators for Desmos, okay? Alrighty, go ahead and work on those. I'll put the answers up.